Let's see what we got here. Maximum frequency of an element after performing operations. You're given an integer array nums and two integers k and num operations. You must perform an operation num operations times, so it has to be exactly num operations on nums, where each operation you select an index I that was not selected in any previous operations. Add an integer in the range of negative k to positive k inclusive to nums at I. Okay, so k is like how much you can change it by. Okay, and you have to do num operations. Return the maximum possible frequency of any element in nums after performing operations. Seems pretty reasonable, understandable. Nums is 145, k is 1, so it can change things by increasing by 1 or less, decreasing by 1. I can only change each index once, and it can be 2 operations. I think maybe I can make these into 4s. That's pretty much it. Or I can make them into 5s. Okay, k is 5, 5, 11, 20, 20, num operations 1. I don't think I can make anything appear more than twice that or is. I guess you can. I guess even though they say you have num operations that you have to perform exactly that many times, you can actually change it by 0. So it's like up to that many times is doable. Yeah, 0. Okay. So I think here it's pretty guaranteed that you want to sort. This is kind of a low acceptance rate. I think this is a lot easier than I would expect. There'd be higher acceptance rates for something that seems so straightforward. Okay. I'm pretty sure that you should sort first. This might be a binary search one. Like you guess the number of elements where you can, or you guess the maximum frequency, and then you determine whether or not it's possible to do that frequency using binary search. Actually, maybe not. Because if you're guessing the frequency, you don't know what number to change things to. Maybe it's monotonic. Maybe it's monotonic. The maximum frequency. Huh. Monotonic. So if you have a list of sorted elements, like if I think about 5 being on the stack, or let's say I'm iterating through the elements of nums, 5 means that if k is 5, I can go from 0 to 10. From 0 to 10. So if I keep a monotonic stack of increasing values where the stack, or maybe not a monotonic stack, monotonic monotonic double-ended queue, or a monotonic deck, where the elements that, no, maybe it's just a sliding window actually. Yeah, sorry. So if I have a sliding window, basically I have a left and right pointer to the indices where it's possible for the left index value up to the right index value to all be kind of within some range. So 5 means that it can go up to 15, I want to say. So if this value is 15 here, that means that I could have 5 plus 5 to get 10, and 15 minus 5 to get 10. Anything that's past 15 would not be kind of within the range of values that 5 could kind of have commonality with. Yeah, okay, so I think this is sliding window. Okay. So I'll have answer 0. Left is going to be 0. So I always slide 1 down on the right, and then I might need to close the window on the left. Okay, so for every right index in the range of n, where n is the length of the nums array, so I'm going to open up the window on the right side to include this value. So sliding window technique where left and right indices are maximum maximally placed such that all values ending with right value can be made into all values within window ending with right value can be made into the same value through operations. Yeah, okay, I think that's right. And I guess it's at most k, or at most num operations is size of window is at most num operations. Okay, so the right side opens, so that means it should be so with sliding window, you add the right element to the window, you close the left side, so close window, which is kind of move left until all values in window can be made into some common value. So this would be while left is less than right, and I think it should be something like nums at left plus 2 times k is less than or equal to nums at right, I want to say. So like 1, so let's say the nums at left is 1, or no, so nums at left is 5. 5 plus 5 is 5 plus k is going to be, yeah, I think that's right. Okay. While nums, I guess it has to be less than, because this, I want to increment the left side in that case. Okay, and then I want to say answer equals max of answer and the current size of the window, which is right minus left plus 1. And then I want to return answer, return the minimum of answer and num operations. Because it can't be more than num operations. I think that might be it. Interesting. 5. Huh, this one's returning 1, where it expects 2. Oh, what am I doing? I forgot the last one. Yeah, I think I need one more. Right minus left plus 1. Actually, I'm not sure why this doesn't work. So right is 0. Okay, let's go ahead and print right and answer. Okay, so the first time it does the loop, it gets 1. Second time it does the loop, it gets 2. Okay, so answer is 3. So answer is 3 at the end of this. So 3 and num operations. Oh. Okay. Oh my gosh, I'm so bad. I need to count the frequency, not the size of the window. Huh. So let me think. So the size, the frequency of the most common thing here is 20. So I think if the window is, let's say, 10 large, right? There's 10 elements in the window, which means that there's 10 possible things where if you perform num operations on them, on all 10, then you could find some common value in the middle of them. I think maybe I just need to tie this in with the most frequent element in the window. So if there's like 5 elements that are tied in the window, and maybe I have only 3 operations, so even though this size of window is 10, that means that 5 things tied plus 3 things that can be changed so that they're tied, then that means I can get 8. So I think I need to track the most frequent thing in the window, like some frequency. Okay, so window values is going to be a set, and window frequencies will be a default dictionary of integers, a way to keep track of it. Yeah. Is that right? Window frequencies. I need to know what the maximum frequency is quickly. Do I need a heap? Maybe I need a heap? Oh my lord. I need to know quickly what the maximum frequency is. I guess this is where it becomes a medium problem, so kind of very simple. So I need to know, so to quickly know what the maximum frequency might be, it could be a heap. The only issue with a heap would be I would need to add information about the number of times something occurs when I add it to the heap. When I add something to the heap, I need to keep track of how many times it occurs. I need to do that only once. Yeah, in which case I would need to probably have either need to change the nums array into something that has tuples of value and frequency, or I need to just not have a right index that increments only once, but have a right index that increments multiple times as necessary. I think I'll start with having a right index that increments multiple times. So while right is less than n, maybe it should be while true. Maybe it's while true. So I start at right. And I need to move right down 1. I think it maybe starts at right is -1 maybe. So I need to always increment right, and then while no, maybe it's left is right. This one. I think maybe I can have while right is less than n, and nums at right let's say current frequency is 0. Nums at right is okay. I think I'm gonna do one extra kind of thing here. I'm gonna add a dummy value to nums to make this easier on myself. All right is less than n, and nums at right is equal to nums at right minus right plus 1, right increments, count increments, or count is the current frequency. Okay, so I think this needs to be a heap. I think heaps to start as just empty list here. And this heap will have tuples of it needs to be tuples of frequency and value. I think this, because it needs to have the highest frequency, it needs to be negative frequency, so it sorts it correctly. sorts it from maximum to minimum. Okay, so I have the right index. It's incrementing through all the things that are the same, and then it needs to add the tuple to the window. So I think this should be window heap Why am I having a set of values? What is the point of the set again? It's to keep track of everything inside my window. Huh. It's to keep track of everything inside my window. I wonder. How big is this? 10 to the 5th? I mean, 10 to the 5th is 10,000 elements. I think that might be a bit too much to have a fixed array. Okay, anyways. I don't know if I need my set anymore. I don't know if I need the set anymore. Do. I do need to know how many elements are inside my window. I need to know how many elements are inside my window. All right, I don't think the set is gonna work. Yeah, I don't think the set is gonna work. Would a queue or a deck work? I push things into the deck. I mean, a deck is just going to be equivalent to having a different variant of the window. A different variant of the window. All right. Okay. I gotta just figure out what I want to do here. I think maybe I'm gonna go ahead and convert my nums into a list of tuples. Yeah. I'll say like tup list, or this is like val frequency tuple, sorted list of tuples where it's going to be value and frequency of that value. I guess this should be how to quickly make this. I guess I probably want to just use right or index equals 0 while index is less than n. say frequency is currently going to be 0. Frequency is this. Frequency and value is going to be 0 and nums at index. I think maybe this should be after this. While nums at index equals value, nums index plus equals 1 maybe, and then frequency plus equals 1. Why am I doing this many? I guess the frequency just can increment here. That's fine. Okay, and then I will then add onto the tuple list, append a tuple that is the value, which is val, and the frequency, which is frequency. And then the index needs to increment by whatever the frequency was. I'm going to go ahead and print this out. Does this work to the very end? I think it does. Print the tuple list. Nums.add. Whoops, this is append because it's a list. All right, looks like it went infinite. So index is less than n, frequency, so I see. While nums at index plus 1. Think this should not go infinite? Oh boy. Index plus equals frequency. Oh, yeah. So the frequency should always be at least 1. Yeah. Still going infinite, huh? Oh, whoops. Oh my god, I'm so bad right now. I don't increment the... This all boils down to the fact that I don't increment index within this loop, but whatever. All right, so 1 appears once, 4 appears once, 5 appears once, 5 appears once, 11 appears once, 20 appears 2 times. Okay, that's what I wanted. So, okay, so I can use sliding window right now. Sliding window. I don't think I need the set anymore. I think I still need the heap. So I don't think I need to have this current frequency anymore. So I think I could probably do with while right is less, well, do a for loop here for right in range. And okay, so here's, I open the window, which means I add the next tuple into consideration. So the next thing goes into consideration by pushing it onto the heap, I want to say. Or maybe I need to remove stuff from the heap and then push it onto the heap. Okay, so let's say current value is the nums at right. This is actually gonna, I want to use the other, I want to use tuplist. Oops. Then I want to have tuplist n be n. Let's say t equals the length of the tuplist. So this should be the tuplist at this right index. So actually this gives me the current value and frequency. So I need to consider that as now part of the window. So I need to move the, oh, okay, yeah. I need to have a number of elements on the window, I think. Window elements is 0. So when I close the left side of the window, that removes values and removes the frequencies of those values from the window. So I guess maybe, I'm not sure if I call this window count. I don't know. It's the total number of things inside the window. While left is less than right, and the tuplist at the left side, the value of that is the value of that huh. This is the correct logic. I have 5 frequent elements. The most frequent element in my window is 5. And I have 3 things that can change. Actually, I don't know. The most frequent thing in my list is 5 in a 10 size window. Let's say the topmost element in the window is 5. And I can only change 3 things. Then it's possible that I don't actually get to 8 because maybe those other variables are at the low end. Others variables are at the low end. In which case it's going to be like the most frequent things plus how many things there can be close enough to it. Oh boy. I was so sure a sliding window could work here. But just because I was so sure doesn't mean I am still sure. Yeah, I don't think that this works. Because the 5 frequent things could be the largest 5 or the smallest 5 in the window, and then you're kind of assuming that somehow they're kind of more in the middle so that anything else can get to it. Huh. All right, so this is just, I think the tuple list is fine. I don't think any of this else works. Is there a way I can use the tuple list and see how many elements are within K more or less than the tuple list? Or let's say I iterate over the tuples. Can I what if I use the tuple list? What if I have actually like 3 pointers? A left, a right, and a center pointer? Okay, okay. A left, right, and a center pointer. And I move the left and the right such that they are around a window around whatever the center pointer value is. Okay. And it's still going to be strictly increasing indices, I think. Okay, so maybe, so window count should still be 0. Left should be 0. Right should be 0, I guess. Okay, so for the center in range of the tuple list, so let's say C value is, or I guess I need value and frequency. C value, C frequency is tuple list at the center. So I need to move my left so that it includes the bottommost tuple that is at least center value minus K, while left is less than center, and the tuple list at left the value of that is plus 2k is plus 2 times k is less than the center value. Is it plus 2k? And maybe it should just be plus k. Maybe I just need to change whatever the left side value is, because I'm assuming the center value is the center value that is the most frequent thing. Plus k is less than the center value, because I don't want to change the center value. Left plus equals 1. And I think this means I need to do the window count. Actually, this is before. Window count minus equals whatever the frequency of the left side that I'm removing is. Yeah, I think that's right. I think maybe, yeah, that's fine. And then while right is less than t and tuple list at right, the value of that minus k minus k is good enough. So is less than or equal to, or I can say here, maybe it's better if I do it like this. C value plus K is more than or equal to the right value. So that means the right value is still good. I'll do window count plus equals tup list the right frequency. Okay. Okay, so I think that might be fine. And then I'll say non-center frequency is going to be the window count minus the center frequency. And the current thing based on the center is going to be current is going to be the center frequency plus however many of these non-center values I can make into the center value. So I guess that should be like max, no, minimum on the non-center frequency and the number of operations. And then answer equals the max of answer and current. I think so. The window count increases on the right side. Window count decreases on the left side. Yeah. Okay. All right, let's see how this goes in the bigger test cases. All right. Kind of a small test case to fail on. So my output here is 1, but it should have been 2. Ah, how interesting. So the center value wasn't actually 88 or 53 in this case. It's like changing both the top and the bottom. Okay. Yeah. I kind of assumed that the center value that you want to fix it to is going to be one of the values within the nums array. That's obviously an incorrect assumption. Yeah, I guess, yeah, this is going to be a bit of an issue. Going to be a bit of an issue. Question is how I want it. So this current solution is fine if the solution would involve changing your values into a value that's already in the array. It is definitely not going to work if it's changing it to a value that's not in the array. I guess in that case, maybe I can do a sliding window to change the stuff that's not, to just do the maximum. Is that right? To do the maximum window that is within 2k of the bottom value and the top value, I guess, maybe. So, like, yeah, okay, sure. It's basics. I guess I want to do this after the top list. This is find max count of any window that is of length 2k in nums. Okay. So I think here I need left equals right equals, or left equals 0. I guess I need to set answer equals 0 here. I'll just reuse answer for right in range of t. So I expand out the window. So this should mean that expand out the window first. I guess it doesn't particularly matter the order. So I'll close the window while left is less than right, and top list at left, top list at left, the value of that is not reachable with the right side value. Left increments. I still need a window count actually. I want to reset the count here. I guess I can just make a different variable. Count minus equals top left. I do want to at left the frequency of that, and then I want to increment the count by top list. Whatever the right side is, and then answer equals max of answer and num operations. No, like min. Sorry, but this should be answer is equal to the max of answer and the minimum between num operations and the current count. Because the current count, yeah, the num operations limits how many things I can actually change. Okay, I think that might be the fix. This is find max count of any based on some center value. Okay. Not bad, not great, but not bad. I think there might have been a way for me to do this without the tuple list. The tuple. Um, if I did a counter, I wonder if that happened slightly faster. Yeah, so if I did something where instead of having a tuple list here, I had, let's say, frequencies is equal to counter of nums, and then I'll make num itself a what's the thing here? List sorted list of nums.keys. Let me see if this is working like I think it should. Nums.keys, which would be frequencies.keys. Okay, so 1, 1, 4, 5. So that could be faster than having a tuple list. Maybe I should call these vowels instead of nums. Okay. Okay, in that case, I don't have a tuple list. So the value is index at n. Oh, this is not necessary anymore, I don't think. Guess maybe I'll say v for the number of values. I guess that could be confused for an actual value. Yeah, whatever. And then for everything in range of v, so vowels, so left at vowels is just gonna give me the actual value. And then the frequency of the value is based on the counter mapping. So it'll be frequencies of this left side value. Otherwise, okay, so here it's going to be frequencies of the right side values. All right, and then same thing here. Center is a value. I wonder if I can just use a for each loop then rather than a for rather than an indexing loop. Probably not. I think I need an index. Yeah. Yeah. Anyways. I don't think I need to see frequencies like this, but maybe it's better to have it. So C value is values at the center index, and then C frequency is the frequency, so frequencies of the center value. So this should get me the left side value. So values at the left. This should be frequency of the left side value. This should be values at right. Frequencies of the values at right. I think that's the same. It's a lot of changes. T is not defined. I think I made that into V. I don't know if this is any improvement. And what do you know? It's not an improvement at all. Okay. Wow, really? Changed all that for nothing. I guess it did. Yeah, the last one was even less memory. Oh my god. And there was some there's a pretty big improvement somehow. Alright, just going back to this one. Guess it was worth a try. Counter never seems to actually speed things up like I think of in my mind. Alright, whatever. Okay, so sliding window technique. Okay, that's the general technique here. So summary, this is going to be count the two methods to get the maximum common value / frequency. One, find the kind of a basic sliding window. Find the largest window where the left value plus 2k is less than or equal to the right value in window. The min of the size of the window and the num operations is what's possible to be made into a common value. Is the frequency. The highest frequency. So like here, I guess what was the wrong case that I had? So for example, if your nums array is 53, 88, actually, so let's say it's actually 53, 53, 88, and your num operation k is 20. Num ops is 3. Your sliding window would include all 3 of these values, because 53 is less than 53 plus 20 times 2 is less than or is bigger than 88, so your window includes all 3. So it's possible for you to modify everything to make it into some common value that's kind of between these, in between them. But noticeably, it's actually not 53 that's being made into a common value, because 88 doesn't subtract 20 to get 53. So that's one. The other one is sliding window with a center value, which is find the largest window where left value is plus k is less than or equal to the center value, and right value minus k is like less is also, actually this should be greater than. Right value minus k is less than or equal to center value. Keep track of the frequency of values. Frequency of values. Use a sorted list of tuples of val comma frequency, and then calculate the maximum frequency of the center value that can be obtained. So here you're using your tuple list of value frequency. I call that T for the length of that list. You get your center value from the tuple list. Yeah, so the tuple list is going to be tuples of center value and center frequency if you get the center index value from that tuple list. Here you close the left side, kind of remove left side, or kind of close the window on the left, which is remove left values outside the window. So if the value on the left plus k can't actually get to your center value, then that means it's impossible to modify this, whatever this left value is, to become the center value. So again, remove that from the list. So the window count is removed by the frequency of the left side value. The left side index increments. Keep on doing that until this is no longer false or no longer true. And then here on the right side, open window on right, add right values if within range of center. So while the right is less than t and the center value plus k, so the largest that the center value could reach is still less than or equal to, it's greater than or equal to what the right side value is. Open the window And then this is the non-center frequency. So this is the number of elements that could be modified to become the center. You take that and the minimum of that value and the number of operations you have to modify, plus your center frequency. That's going to be whatever your current Windows kind of frequency to modify to become the center value, and then answer becomes the max of that in the current. Time complexity, this can be O of n to create the tuple list of value called frequency. Also, O of n log n to sort the array. I guess maybe, yeah. So overall should be O of n log n. There was also the processing the tuple list to get the answer value from both methods is O of n, based on basically the number of tuples, which is at most n. Space complexity, this should be O of n to create the tuple list. All right, cool beans. Oh, someone actually wrote something